Okay, so some of y'all said that you've heard your parents talking about taxes before. It's coming up real soon. So you probably heard them talking about it a lot, maybe, like stressing out, trying to get all their taxes and stuff filed before that due date. Okay, well, you guys are called dependents. Did y'all know that? So your parents claim you as dependents because you depend on them. They have the jobs, they earn the money, they provide the things for you, right? So you depend on them in a sense to make sure that you're taken care of. Well, math also has dependent things as well. We have independent variables, which basically determine what happens to the dependent variables. So we're going to talk about the difference between the two. Today, all we're practicing is naming which one's the dependent, which one depends on the other, which one will happen no matter what, and then which one changes based on the independent variable. So we're going to define both of them first so that you understand the difference between the two. We're going to start with the independent because the independent one is the one that is going to continue no matter what. Okay, the other things are going to depend on that. So independent is a quantity that stands alone and is not changed by other quantities, and it's most often going to be your X variable. But then you have your dependent variable, and that is a quantity that changes.
It's a dependent clause.
Depending on another quantity. So there is something else that's causing it to change. Something else is happening, and when that happens, your dependent variable is changing as a result of the rule most often known as your Y variable. What else has X's and Y's?
Like coordinate graphs.
Coordinate graphs. So guess what we're doing tomorrow?
Coordinate graphs?
Coordinate graphs again. Okay, 1, 2, 3. Eyes on me.
1, 2, eyes on you.
Guys, we're already almost done with our notes for today. Okay, we have an example. It says every 10 days, Anna adds $20 to her savings account. If she saves for 80 days, then how much money would she have? We're going to write an equation and we're going to make a table. But before we do, I want to talk about each part of this problem. Okay? So starting out, let's talk about what the independent variable might be. Okay, if I'm comparing something, I'm comparing money because I've got amounts of money here to what else? Days, because I'm earning money over a certain number of days. Okay, well, what is going to continue on no matter what? Days. Days keep going. Whether or not I keep saving every day, that may stop at some point, but the days will keep going. So that means that the X variable is the number of days of saving money. Here's a hint too. Most oftentimes, your X variable, your independent variable, is going to be some form of measurement of time. Days, weeks, years, hours. Okay, so things that just continue. Time, if time is involved whatsoever, then that's going to be your independent variable. More times than not. Okay, almost every time. Notice I'm not saying always.
Always.
But most often, it's going to be your independent variable. Okay, Y. So if X, or my independent, is my days of saving money, then the Y, or the dependent variable, is the what? What depends on the number of days? The money saved. So what we're seeing here, we're going to fill in these next pieces in just a second, where it says as X blank, Y blank. Okay. So I'm going to read it again. Every 10 days, Anna adds $20. If she saves for 80 days, how much money would she have? Okay, let's go ahead and label our table here. X is going to be my number of days Y is going to be my money, or money saved is fine. I realize I've left several blanks blank right now. Okay, before we continue on to our table, y'all remind me, what is my independent variable? Days, which is represented by X. My dependent variable is money saved, which is represented by the Y variable. Okay. So if I have 10 days and I add $20, what is happening in my table? How do I get from 10 to 20? Multiplied by what? I'm multiplied by 2. So my relationship, remember how I told you that we're leaving certain things blank for a minute? The relationship that's happening in my table here from my X variable to my Y variable, my independent to my dependent, what's happening is we are multiplying by 2. That's the relationship. So what that means is as X increases by 10, Y increases by how much? By 20. As X increases by 10, Y increases by 20. So then I would know that my next values in my table would then be 20 and then 40. Then I would have 30 and then 60. And then 40 and then 80. And then 50 and 100. 60, 120, 70, 140, and 80, and 160. Okay. Now notice there's still one more blank. It's right there by that squiggly arrow pointing to my table. It says, write an equation. We just made the table first. I want you to look at that table. Again, notice that I am multiplying by 2 each time. What am I multiplying by 2?
Money and days. Money and days. Or money saved.
What's being multiplied by 2?
The dollars. Days.
The number of days. Do y'all see? Days times 2 equals 20. Days, 20, times 2 equals 40. So when I go to write my equation, what I'm going to be doing is I will write y equals, what does y equal? X times 2, or we would typically write it 2x. The number first, then the x. That's your equation. Tomorrow we're going to do more practice with tables and equations and then actually plotting points for that equation. Okay, that's all we're doing today. Today we are practicing naming independent and dependent variables. Practicing naming it. That's it. So determining what is my independent, my standalone value, and then what's the other one that depends on that.